This is a patent filed in 1824 by Jeremiah Chubb for his improved detector lock. At the time of its invention, this was considered the most secure lock in the world, and it was deemed by many to be impossible to open without the correct key. It was so secure that nobody was able to pick one until 1851. Chubb patented his first detector lock in 1818 and continued to publish improved versions in 1824, 1833, 1846, and 1847. These locks were so effective that Chubb became the sole provider of locks to England's prisons and postal services. I discovered these locks while I was scrolling on Wikipedia a few months ago and wanted to learn more. So I attempted to recreate my own version of Chubb's 1824 detector lock, and in this video I will show you how this lock works and how I incorporated it into this 3D printed vault. This is a 3D printed vault with an 1824 Chubb detector lock. If you have the correct key, this will operate just like you expect. Just insert the key and turn to lock or unlock. But this has a special trick to prevent intruders from picking the lock, and it even alerts the owner that an attempt was made. This green piece is called the detector, and every time we turn the key, it is raised by these gold pieces, which are the levers. The levers must be raised to the correct height for these cutouts to align and the bolt to move. Now, watch the detector as I lift one of these levers, and just at the point where it's lifted too high, the left side of the detector drops down into a notch in the bolt, which will completely bind the lock. This would happen if someone tried to pick the lock. They would inevitably lift a lever too high and unknowingly trip the detector. From that point on, even if they can align the gates, the lock won't open, rendering it unpickable. Now, when the owner returns and tries to unlock this, they'll find that their key won't unlock the door. This is an indication that someone tried to pick the lock, which is obviously useful information, but at this point you might be wondering why this is a good thing. The lock is jammed and the key won't even open it. Well, there is one more trick. If we turn the key the opposite direction, it will reset the detector and we can unlock the door. I made this lock as a prototype, and I'm going to use it to show how this lock works, and I'll start by removing the levers. The red piece is the bolt, the blue piece is a regulating slide, and the green piece is the detector. The first tooth on the key moves the bolt, and when it's extended, we can keep turning clockwise to engage the regulating slide. I'll trip the detector, and now you can see the bolt won't move. If we turn this around, you can see that there's a hook on the detector which grabs into this notch in the bolt and keeps it from moving. Now watch what happens when we engage a regulating slide. The detector is reset. Now I'll take the first lever, which is clearly labeled with a number 1, and add it to the lock. As we turn the key, the second tooth is sized to lift the lever to the correct height. Each lever corresponds with a tooth on the key, which means we can rearrange the order of the levers to create unique keys. Since there are 4 levers, we have 24 possible combinations, so I painstakingly modeled, printed, and tested all 24, and I'll include a guide in the model description. So that's the lock. Now let's get into the vault itself. Aside from the 3D printed parts, this design uses threaded inserts, screws, 5mm metal dowels, and a skateboard bearing. The door itself is held together with 4 screws on the back, so it can easily be disassembled and the lock can even be rekeyed. I designed 3 different front covers. One is totally open, so the lock is fully exposed. One is enclosed like a real vault door. And one has an acrylic cover to showcase the lock but prevent tampering. At the beginning of this project, I thought the open or acrylic versions would be my favorite because the lock would be visible. But I actually like the enclosed version the most. It took a few tries to get the design right, but I think it looks amazing. I'm posting the files for free on Makerworld, so if you have a 3D printer, you can try to make one of these for yourself. Please keep in mind that this is a complex mechanism, so if you decide to try to make one of these for yourself, make sure that the tolerances are dialed in on your printer. The first step in the vault assembly process is to take the base frame and glue in the hinge pieces. The hinge pieces only fit into their respective corners, so it may take a moment to get the orientation correct, but it's really not that hard. Next, we're going to install the vault bolts and central gear. Place the bolts onto the frame and push them into the retracted position like this. Then, take the central gear and add a bearing. Now, I want to pause for a second and stress how important this step is. The gear must be installed in the correct orientation relative to the bolts, or the lock will not work. The simplest way to install the gear is to make sure the bolts are retracted, then install the gear with the 4 spokes pointing to the 4 corners of the door. The gear teeth should align, but it may take a moment to get everything in place. Take extra care to make sure it looks like this. It needs to be exact. The frame cap goes on over the bolts, and this part looks symmetrical, but one side is actually slightly tapered, and this is indicated by arrows on the underside. Just find the arrows and orient that side opposite the hinges, on the right side of the screen. Next, we're going to add the body of the lock, which I prepared earlier by gluing in the spring and 3 metal dowels. I designed this little jig to hold the dowels in place while the glue dries to ensure they're perpendicular, and this is optional, but I highly recommend it because it's a pretty quick print and it really helps with the quality. The spring glues in place easily. I recommend printing this spring in PETG because it needs to be springy and it will stay more elastic for a longer time than PLA. Before I assemble the lock, I want to take a moment to thank the sponsor of today's video, PCBWay. With PCBWay, you can 3D print your projects in a wide variety of materials, including nylon, polycarbonate, and even metals like titanium and stainless steel, and there are plenty of color and finishing options. This key was printed in transparent resin, and it looks incredible. It's perfectly transparent, and there's no indication that it was 3D printed. They also have a wide variety of materials for CNC machining, so I got this acrylic panel cut for the front, and it's so clear it's hard to see. Thank you to PCBWay for sponsoring this video. The lock body drops in place like so, and we're ready to add the lock bolt. For this step, the vault bolts should be fully extended, so rotate the central gear until they are fully exposed. The lock bolt has a small rack on the bottom which I glued in place earlier, and this rack interacts with the central gear. Place the lock bolt onto the frame as far right as possible, and it should just drop in place and the gears should align. Test by pushing it back and forth, making sure it can fully extend and retract the vault bolts. The regulating slide goes on next, and this too should be PETG. It just sits in the lock bolt, and now we're ready to test the vault mechanism with the key. You should pause and test this thoroughly to ensure that the key will fully extend and retract the bolts. If there's a problem, you should go back through the past few steps carefully and make sure the alignments match the video. Now we're ready to add the levers. For this vault, I'm just going to install them sequentially, so one goes on first, then number 2, and so on. But as I mentioned before, you can pick a random key and lever combination to make yours a little bit more secure. After the levers, we'll add the detector, making sure the hook is facing down. Before moving on, test out the lock and make sure everything's working, including the detector and the regulating slide. Now we're ready to install the cover, and for this video I'm using the open cover, but this step is the same whether you're using the closed or the acrylic covers. These have 4 threaded inserts, which I installed earlier. The cover will slot into place and is secured to the door with 4 screws on the back. The door handle is made of 3 pieces, with 2 connections in the remaining 2 corners, similar to how the hinges were connected. This can be a little tricky, so I'm just going to show it without glue, but you can imagine that you need to add some glue into the handle and into the door piece itself, and then slot everything together. And there we have it. The door is complete and everything works beautifully. So it's ready to add to the jamb. The door connects to the jamb using 2 metal dowels. Just slide them in and it will create a nice secure connection. Now I'm going to prepare the box. The first step is to add some weights into these recesses in the back. This is optional, but without added weight, the box will tip over when the door is open and the box is empty. I added 6 metal nuggets, which each weigh 1 ounce, but you can use whatever you might have laying around. The cover is glued over this to hide all the weights and to keep it looking clean. Then I added some more glue and secured the shelf into the box. Finally, it's time to add the door to the box. Just add a bunch of glue around the perimeter and be careful that none squeezes out. Then just add the jam and push it all together. And this project is done. It took a ton of work, but it came out great and the experience was both fun and rewarding. I learned a lot about 19th century locks, and I'm thinking about recreating some other 19th century designs in the future, so please let me know in the comments if you'd like to see more, or if you have any suggestions for locks. I forgot to mention earlier that this entire vault prints without supports, and I spent a great deal of energy trying to optimize the design for easy printing, simple assembly, and minimal gluing. The key itself does require supports, but you can use organic supports and it's very easy. If you got this far, please consider subscribing to my YouTube channel, and that's the best way to show your support. If you enjoyed this video, please hit the like button and leave a comment. Thanks for watching.